I'll send this link here. All right, see Nayoka. Nayoka.
Afternoon, sir.
Afternoon, Nayoka. All right, checking if you're there. All right, guys. So Carla, you said you saw a definition for volume. What does it say?
The space taken up by an object in 3 dimensions.
All right. All right. So I hope everybody have that. All right. That was sent before. So yeah, volume is the space taken up by an object in 3 dimensions. All right. So never forget that. That is very important. So that was what we would have done in the last class. So now you're going to remember that volume is space in 3 dimensions. All right. It's called 3D. All right. And what are the 3 dimensions we're talking about here? What are the 3 dimensions of volume?
Length, width, and height.
All right, very good. All right, so length, width, and height. All right, so let's go with height here. All right, good. So that's what. So when you hear about 3D, it means that you can see things in 3 different directions or 3 different sides. All right, length, width, and height. All right. So then, and then that basically means to calculate volume. So volume is actually affected. Or no, let me just say it. Volume exists rather as in the, well, let's say in the 3 states of matter. Would I go by extension and include plasma though? Plasma is a 4 state of matter, but does plasma have volume? Never heard it talk about it though. So I'm gonna leave it out for this one. Possibly a plasma has volume, but when we talk about plasma, we reach a different type of physics. You know, that's like quantum physics, which is way above your level. So volume exists in the 3 states of matter. No. Right. So because it exists in the 3 states of matter, there are various instruments that we can use to measure volume. All right. No. So now, all right. So we're going to look at volume in solids first. I mean, all right. So volume in solids may be measured by or in fact, let's change may to can, because okay, measured using. All right, so when I say first one is using mathematical formula. All right. Or B, we could say using, and this is gonna be like for your first lab that you're gonna do, is gonna be measuring the volume of an object here. So using mathematical formula, or using the second one, which is using all right. All right. But that word that underline, but it can call it, what is it?
Displacement.
Displacement. Yeah, using a displacement method. All right. So these are the two ways we're going to learn how to, measure the volume of an object. Now, no, I'm gonna put something in bracket. All right, so in fact, let's go to another slide here. All right, mathematical formula. All right, is used all right. So mathematical formula is used for regular solids. All right. Now, do we know what we mean by regular solids? But you know what a regular solid is? All right. So let's go. What shape is a ball? Or what is the name given to the solid that that makes up the shape of a football?
Sphere.
All right. You call it?
Sphere, sir.
Sphere. Oh, yeah, well done. Sphere is definitely one. Football is a sphere. Example of that solid object there. All right, good. Yeah, sphere is one. Any other that you know? The other one is regular. Yeah, most regular solids have a name, have a specific name. So like sphere is a specific name for a type of solid. And somebody tell you look to get a sphere or to make a sphere, you know exactly what it should look like. Tell me some other solids that if they tell you the name of it, you'll be able to make it or know what it look like.
Cube.
Cube, very good. Cube is one. All right, which other one? Have many more.
Cuboid.
Okay, cuboid.
A pyramid.
Pyramid, yeah, very good. So hearing from Kristen and Chrisanti. All right.
Cone.
Cone, yeah. Look at that. You did these in maths class?
Yes, sir.
All right, so sphere, cube, cuboid, pyramid, cone. Many others. One important one that I don't hear yet. Yes, Chrisanti, I think I hear you saying. Did you say cylinder?
Yes, sir.
All right, very good. Yeah. All right, so cylinder. No, for physics CXC purposes, cylinder is common. Sphere and cubes are common as well. So these are the ones we're going to sort of focus on a bit more. So like the sphere, yeah. So like the sphere now, and the cube and the cuboid, the cylinder. All right, for CXC purposes, we focus on those more. All right, now, you'll also get questions as to like to work out the volume of a sphere and cube and cylinder. Those are common. All right, so now, so everybody should know what a sphere look like. It's 3D. So if you're gonna look at a diagram of it, it's gonna be a bit challenging because you can only see 2 dimensions at once. The third dimension usually you have to turn it, rotate it. Let's see if there are any. Well, 3D models are here. So let's see what happens here in this program. If you find a sphere and see how they design a sphere in this program. Let's go and look at that. We have some spheres here. Let's see. Like a red sphere. Let's insert this and see what it looks like. Okay. Let's allow it to rotate. So it's not doing that. Oh yeah, actually allowing it to rotate, but It'll be hard for you to see it. But everybody is seeing this sphere?
Yes, sir.
Yes, sir.
All right, good. All right, so that's a 3D models here. All right, and let's try and insert a cube. See how that looks like. Actually 3D modeling. And then some of you guys maybe later on, I mean, in a lot of careers, even medicine, this is what they do sometimes before they do a surgery. They get the patient body in a 3D model and they go, then they rotate it around to see, look at this avatar. Now, all of these here, and once I can cut it, and
That in a great atom.
you do that here?
No, stars are secret atom when they do it, sir, when they were performing a surgery.
Yeah. And what they show the model of the body.
Yes, sir.
Right. So that's why you have to learn these things, right? That's why you need physics to do medicine because physics has a lot of those information. So but then notice that for this, I can use anything, everything here is 3D. I can bring in any object, any regular, but then the thing about it is that the regular solids, you can use a formula to calculate the volume. But for the irregular one now, like for example, like if we use an avatar, for example, that would be an irregular solid. And you will be an irregular solid in the sense because you can't say you don't shape like a sphere or you don't shape like a cube entirely. So some parts have different shape from others. And so because of that, you're a complex solid, which makes you irregular. So we have to use other ways to measure your volume. All right. Now we're gonna look for our cube and see if we can get a nice model to go beside that one there. So nice cube here. And I'm gonna insert that one. And should be the cube, but interesting here. Oh, it can be rotated. So this is red. A nice cube there. All right, everybody should be seeing that. All right, and of course, let's see the difference between this and a cuboid. But you know the difference between a cube and a cuboid?
Yes, sir.
Okay. Chrisanti, all right, what's the difference, Chrisanti?
Sir, cube equal sides one by no equal, sir. All of them not equal.
Very good. Yeah. I hope everybody hearing that. All right. What Chrisanti is saying is that all the sides on a cube are equal and all the sides on a cuboid are not equal. All right. So yeah, that's right. So this is really our cuboid. So at least that you leave here knowing if you didn't know before. So let's put these let's insert. Yeah. So we have our sphere. We have our cube. And we have our cuboid. All right, hope everybody's seeing this now. All right. So there we have our regular solids. Our cylinder, we don't have any space here. So let's insert that because since says one of those things that CXC could ask about. Let's get our cylinder in this. All right. So here's our cylinder. Using sort of red theme today. All right. Anybody favorite color is red? No. Well, don't blame you. Red is a dangerous color. All right. So all right, so we have here, this is our cylinder. And there you go, we have our shapes here. And of course, if you want to go further and look at pyramids, You know, yeah, different types of pyramids, actually. But you know the different types of pyramids? Buddy? Right. Yeah, you know, you have your square base pyramids, you have the
Triangular.
triangular.
Triangle.
Yeah, I got wild there, but yeah, that's true. Square and triangle. Definitely. That those are different types of pyramids. All right. All right. So yeah, not actually seeing some weird pyramids here though. Not the ones I'm looking for. Unless they have I'm not sure you call this a pyramid. But then of course a pyramid would be different from a prism. Pyramid is like that. Can rotate it. Something like that. All right. You get a pyramid. Looks like a square here, and then we have rectangle on the sides here. For you seeing that. So that's our pyramid. All right. But, yeah. See no. All right. So again, these are those examples of our regular shape, guys. And I won't go much further than this. It's just that at the end of today, your objectives are um to basically remember what is said here. The volume of objects exists in all three states of matter here. Mathematical formula is used for finding the volume. And then we put here of regular for regular solids here. All right, so regular. All right, so regular solids, and then of course for irregular shape solids. All right, so that would be basically for today. Since I think this is the time here. So we have sphere, cube, cuboid, cylinder, pyramid. Surprised nobody told me prism though. But they know what a prism look like. All right. Yeah, prism. Yeah, rectangular prism here. And turn the next class we'll find out whole prism concept here. Okay, triangular prism here. Yeah, we're triangular prism. All right, so I can actually, it gives me option for select two. All right, let's insert that one. All right, and yeah, let's see if we can allow me to rotate it, but it's gonna be like a prism. All right. Anyway, that's it, guys. So next class. So next class now we meet with work questions that relate to the each of these solids, right? So for next class you'll be practicing to find the volume of cylinders and of spheres. So you can read up on that for next class. All right. Anybody have any questions?
No, sir.
Okay. All right, lovely. So let's just go through the resistance, you know, everybody here except and this except Naoka is not there. Let me just put your name. All right, so all right, so Naoka. And of course Ricardo was there, but he got kicked off, maybe have Wi-Fi problems. Right. So I have some Wi-Fi trouble. All right, guys. So thanks for coming out today. All right, and remember, guys, just stay with the program. Try and learn as much as you can through this, online platform, and don't fall back. All right, don't fall back. Because in the end, it's going to set you guys back. You have to stay with it. Just have the discipline to go through the notes and stay with it. Do the test them and pass them and stay with the information. But you hear that?
Yes, sir.
Yes, sir.
Right, good. All right, enjoy the rest of your day. Yes, go ahead. Okay. Yeah, as I say, enjoy the rest of your day, and I'll see you guys on Thursday.